Hey guys, this is Neil at FabBlocker Hackerspace, or SpaceXULA in the IRC or the forums. Today we're going to be doing a short tutorial on Skeinforge. Skeinforge is a program that turns your solid model into a G-code file which has the object sliced along the Z-axis at a set interval and a G-code pattern for the X and Y axis with a perimeter and the infill. I'm going to be showing you how to actually set this up and try to calibrate it. It takes 3 steps. First, you have to alter your firmware so that your X, your Y, and your Z axis, whenever Skeinforge tells your bot to move 100 millimeters, that it does actually move 100 millimeters. Next, you have to physically describe your machine to Skeinforge so that everything's properly calibrated. And then you have to alter the ratios so that the extruder puts out enough plastic to fill in and not overfill each layer. So first things first, what you're going to want to do is calibrate your firmware. So you're going to load up whatever program you're using to control your RepRap. So that could be Replicator G, Pronterface, or RepSnapper. I personally suggest Pronterface. What you're going to do is load it up, and you're going to tell your machine to extrude 100 millimeters of filament. Very likely, whenever you tell it to do this, it's only going to extrude like 10 millimeters. So whenever you hit extrude, your extruder will move very little, sometimes very slowly. It will just crank out a small bit of plastic. Now, what you need to do is actually measure this, or put a mark on your plastic so you can see how much it moved. Easy way I found to do it is to actually mark a clear drinking straw 100 millimeters, and then run a razor blade down it so that it will wrap around your filament like this. So I'll go on, use it as a jig, and then you mark your filament 100 millimeters. Then you tell your extruder to run forward 100 millimeters. So it'll probably run 5 millimeters forward. You then measure the amount that it actually moved. So we'll go ahead and say that it moved 5 millimeters. So you would have your 100 millimeters, which is what you told it to move, and it only moved 5 millimeters. Then you're going to go into your firmware, and you're going to see what the current E-steps per millimeter is on the extruder. And you're going to multiply that times that. So this would be 20 times whatever the current E-step per millimeter is. Now you need to do this again. So again, you put your jig on, you mark your plastic again. This time when you run it forward, it's probably going to run forward nearly the full distance, if not more. So this time it's probably going to be 100 millimeters over either 95 or 105 or somewhere in between. And then whatever that ratio comes out times the current E-step per millimeter. You want this value to be as accurate as possible. Also, you want to check your X, your Y, your X-axis going along this way, your Y-axis going along this way, and your Z-axis up and down. All 3 of these need, and the E-step on the extruder, all need to be very, very precise for Skeinforge to work correctly. Next, you're going to go to physically describing your machine to Skeinforge. So what you're going to do, and your plastic, so you're going to go into dimensions. You're going to pull out your caliper again, and you're going to measure your filament. Now be sure to check along the X and the Y axis in multiple places along your filament, because many filaments are not 100% round, and there's a little variation over the course. So just pick like 5 inches, 5-10 inches, and then check different areas along that. You're going to enter that into the dimensions plugin. Now you have, when it moves 100 millimeters, you have 100 millimeters, and you have a proper diameter plane geometry that gives you the volume of plastic that's going in. So now Skeinforge knows the volume of plastic that's going in. You now need to tell it the amount of plastic that's coming out the tip of your nozzle. This is a Makergear 3.5 millimeter nozzle, or 0.35 millimeter nozzle. So what you're going to do here is, as a starting point, now this isn't the final authority on it. Your carve is something that you can alter to whatever you want to do. But typically, with a 0.35 nozzle, you're going to go ahead and do like a 0.32 layer height. Just a little bit less, like 20% less than what the actual size of the nozzle is. That's a good starting point. So you're going to enter that as your carve value. The carve value actually is used a good bit around Skeinforge as the base for other calculations. So you need to sort of keep that number in mind as we're going through this. So you've set that. You also need to set your speed, or your feed and your flow. Your feed is how fast your nozzle moves in the X and the Y axis, and in a different position there's a feed rate for the Z position. So what this is going to do is let you know, or you're going to tell the machine the feed rate. Now you need to make the flow rate, which is the rate at which this extruder moves forward, match your flow rate. Needs to match your feed rate at the beginning. Now later on, once you've got everything calibrated, you can tweak. Of course, everything's tweakable in Skeinforge, but as a base to start out with, you always want those two to be equal. So now that you have your feed rate and your flow rate, which are both set out of speed, and you have your layer height, which is determined out of carve, I suggest your first calibration print be the Movember ring of Thingiverse. You're going to download the Movember ring, and under carve you're going to go ahead and turn off extra layer or extra perimeter layers. Reason being is if you leave it on, it's automatically going to fail on the ring. Any thin-walled item you need to not have extra, or any thin-walled item you need to not have extra walls, or it will mess with it. So anything below 3 millimeters across, the extra lines will affect it. So a little explanation of how important your carve level is. The way the carve level, your layer height, these right here, affect is by the size of the carve. Is, think of it as a sphere that is going around this part. So the smaller the carve is, the more lines it's going to try to draw into the part. So if it's a big ball, or if it's a big layer height, what's going to happen is it's going to draw this very primitively. It's not going to use that many lines. But if you can get the carve level low, then it's going to, on the X and Y axis, it's going to be much finer detailed. So what's going to happen is with your carve is going to, it's like, say for instance this was the ring, the carve is going to be the value that is used to draw the perimeter of the object and then the infill of the object. On this thin wall item, or on the thin walls of the ring, you want to make sure that at least one pass is for infill. Just because the ring itself is 2.5 millimeters across, there's no real way using most of the nozzles we would use that would ever not be, because most nozzles are below 0.5 millimeter. So there's not really a way for it to be able to draw it without them turning into like that, where it's not right. So you skein it, you process your file, and what happens is you now have your pattern for your X and your Y axis. You then are going to alter the ratios. The ratios, which are the width over thickness, determine how much plastic gets put on the blue part, which is the perimeter, and the yellow part, which is the infill. Now, the good thing is that thickness is a number you know. That's actually the thickness that it's going to use is determined by the carve value. So let's go ahead and say, for instance, we made these layers 3.5. You know that 0.35 is your thickness. So what you're actually controlling with this ratio is the width. So that means that if I were to, let's see, if the ratio was 1, then what you would be describing is a cylinder. Now, a cylinder doesn't work very good for 3D printing because as the layers build up, they don't stack. They don't have much, because there's not much way for it to adhere very well. So the base level for the ratio that is set in carve for the perimeter and in fill for the infill is 1.7. 1.7 looks like this. So they're both sort of ovaloid style extrusion. That's what it's assuming. Now, if the number goes too high, like let's say for instance you were to just go straight to 2.0, then what would happen is it would assume that you're really needing to squish out a lot of extra plastic. And what happens is layer upon layer, it actually will cause a bunch of extra goo, which will cause all sorts of havoc in your prints. A 0.5 layer height would be like this. It would be just tiny. Or a 0.5 ratio would be very little plastic would actually go into each one of the layers. So somewhere around 1.7 will be the number. Now, it very well might be down to 1.5, it might be up to 1.8, but it'll be somewhere in between those numbers. So, you have your ratio that is set in carve, which tells how thick the outside perimeter should be. You have your number out of fill, which tells how thick the inside line should be. These are the two primary levers you're going to use to control how much plastic is laid down on each layer once you've already set your carve. If everything else is set up to match your machine, this should work. And to give you an idea of what a layer should, the reason I like this part is because since you have that one ring of infill there, it makes it really easy to see whether your perimeter is too thin or your infill is too thin or thick. What you want is the top of this ring to be flat. You want them to match perfectly. And if they match perfectly, what's going to happen is there's not going to be extra plastic built up inside the mustache part. So you should get a nice, pretty mustache. If you're if everything's running right, the mustache should actually be two independent mustaches. And it gives you, and also it's easier to see it with this. If you print the block, it's really hard not to hide your details with the block. And also, since the block takes 20 minutes, it doesn't let you go through iterative process to get these ratios right, because you want them to be very, very precise. Beyond that, that is generally the way that you calibrate Skeinforge, and we are 13 minutes in, so I will cover one other issue, which is temperature. With temperature, to find the easiest way to calibrate your temperature is to actually use line infill. You don't always have to use line infill with your normal prints. You can use whatever infill you want, but line infill gives you a distinct advantage in that line infill is going to cause the plastic to print out into air. If your plastic is too hot, the plastic is going to sink between these two layers, and it's going to fall down with each layer. This can be combated two ways. You can either turn the temperature down on your extrusion, which has consequences, but you can turn it down so that it will print at a lower temperature, so it won't sag in. The only problem is the hotter your nozzle is, the faster this extruder can run. And you sort of have a build-up of either good qualities or bad qualities with the reduction of temperature. Yes, with the reduction of temperature, it's easier for the infills to work good. But the problem is that the colder your hot end is, the slower this extruder has to go. The slower the extruder has to go, the harder it is for you to, the slower it goes, the slower this can go, the slower your X and Y axis can go. And the slower your X and Y axis go, the less your resolution is on the Z axis. So instead of looking more like the model you're actually trying to print, it looks more like this. It has the strata in it stronger. So anyway, I hope this was helpful and at least enlightened you in some ways, and hopefully it's not completely incorrect. So anyway, have a good day.